So we have Dr. Ameen Sayed with us. So Dr. Ameen Sayed, he is director for ZAF Infratech Private Limited. After completing his master in structural engineering from BITS Pilani, he dedicated 6 years in the development of pre-stressed precast concrete pavement (PPCP) and completed his doctorate in the same. He constructed India's first PPCP road. He has also developed design methodology for PPCP using his expertise in the field. He is member of the prestigious IRC H3 committee dedicated towards the development of PPCP IRC code. And he is also actively involved in construction and promotion of his brainchild PPCP roads as they are more durable, economical, environmental friendly, and their construction time is significantly less. So I would invite Dr. Ameen Sayed, and he will be speaking with us today on the topic of design and construction of pre-stressed precast concrete pavement. So Dr. Ameen Sayed, over to you.
Thank you for that lovely introduction. Precast technology really needs these kind of conferences because there's a lot of potential, but it is quite untapped. With that, I would like to start with my presentation. As ma'am has already mentioned, I've been working on pre-stressed precast concrete pavement technology. I've completed my PhD in this topic and presently running a company CC Precast Solution, which is involved in the construction and design and overall management of precast concrete pavement technology. This basically started off with the guidance of my PhD mentor, Dr. RS Sonparote. He is an associate professor at VNIT, and the idea of precast concrete road firstly came to him because of one situation that we faced. So that inspiration was mainly because we had road construction ongoing right in front of our VNIT campus. So his home is basically like hardly a kilometer from there. But just because of that under construction concrete road, he had to travel almost 3 kilometers just to reach his place. So he had this thought, why can't this process be faster? Like if you make a bituminous road, that works out very fast, but concrete road, it takes a lot of time. So he gave me this responsibility to check if there is any scope of development of precast concrete road. So that's why I got into that literature review. And by a simple math, we found out that like a construction of simple 1 kilometer road requires an additional user cost of 58 lakhs just because of that diversion. Another issue that we soon faced soon after the completion of the project of the concrete road right in front of our campus. This is the same picture of that road. There were tire marks, there were pug marks, there were footprints, there were all kind of problems in the quality of that pavement. There were cracks. All of that was because maintaining the quality at site of a concrete road was really difficult because it is very difficult to stop the crowd, and especially when there's traffic jams just next to your road where the diversion is. So people tend to ignore the freshly laid concrete and drive over it whenever required. We targeted this problem, we investigated this problem, and this is the statistics that we got. Traffic congestion in itself causes 1.47 lakh crore annually in few metro cities in our country. So the cost due to traffic congestion is mainly because of the user cost and because of reduction in quality and the cost because of the road closure. So all of that cost piles up. So how can we reduce that cost and how can we optimize this process and make a better quality pavement? So adding all of that, we moved on to this technology. This is a brief video. I'll play it now. So the simple process goes this way. The milling is done. So the top BT surface is removed and a simple leveling course is laid over it. And the panels are transported to the site and simply lifted via crane and placed. So once the panels are placed, if there is any minor undulation because of the base, they can be fine-tuned, lifted, and the base is grouted. Once the base is grouted, the panel fixes to its own position. Then the panels are joined using dowels. I'll show the details in the coming slides also. And the gap in the joints are filled with the grout. After this process, the traffic can be allowed immediately. This process basically can be done even overnight, and as can be seen here, ramps can be provided. simple ramps, and the traffic can be allowed in the morning. The main advantages that we saw that can be obtained from this technology is fast construction, and as has been said by the previous presenters, it can be really high quality because of the controlled environment in the casting yard. If we use pre-stressing, pre-tensioning, there can be considerable material savings there. So, of course, that material saving reduces the burden on the natural resources, makes it more eco-friendly. And we are on in the process, I should say, of development of a precast panel which can be removable. So, replacing any pipelines or conduits beneath the road can be really easy. You can remove the panel, lay the pipes, and again use the panel. The limitations is it does not address to a weaker base, as in any road requires a strong base. So if the base is not right, not strong enough, so either concrete road or bituminous road or precast road will be damaged by it. And availability of casting yard is not that much of an issue. One casting yard can easily cater to a 70-kilometer radius, so that is good enough. Skilled labor is required for any precasting work. And of course, lack of awareness and acceptance is a big issue for any precasting technology to be accepted, especially in our country. The applications that we have explored till now, one is intermittent repair. So if few of the panels in any concrete roads are damaged, you can remove it and replace it overnight. So that way the traffic won't be congested. You can easily replace the damaged panel. Road intersections is one of the main application because and you cannot close the road for construction of concrete road. You cannot close the intersection for construction of concrete road, right? It requires curing, and if curing is done slowly, intersections cannot be held up. So precasting can help that a lot. Temporary roads is one aspect which we are still exploring, wherein let's say there's a construction site, maybe a city, what you say, a layout area or something, where temporary road needs to be laid in one direction, then permanent road needs to be laid in other direction. Same precast panel can be used for both. Bus pads and helipads can be constructed by this methodology. Airfields can also be done by this application. And as I said, it is easier to do underground utility maintenance. There are basically two critical aspects to precast concrete pavement, particularly. One is the jointing of panel, another is the base preparation, like how strongly you prepare the base. So one of the methods of jointing that we developed is lateral dowel method. As can be seen here, two panels are placed such that their teeth are interlocked and a rod is inserted between them. So both of them are locked, and as you can see, the pipes coming out here. So these pipes are cut later on, and these pipes are used to grout the slot. There are three or four methods that we have tried within the campus, VNIT campus. One of them is the string method, like the dowels can be inserted in one panel. So every I'll just put a disclaimer that every panel needs to be joined with a solid MS dowel. It is the same thing which is done in regular concrete road. Just that in this case, the panels are independent, so the dowel needs to be arranged somehow. So one method is lateral dowel, which I explained previously. Another is this sliding dowel. So the string is there, you just pull the string after placement of the panels, and the dowel is pulled between the panels, and the slots can be grouted later on. Another method is the sliding dowel. Like the dowel can be inserted in one panel, and through these slots it can simply be pushed into the another panel. This is the string one which I explained previously. One of the methods that we developed within the campus of KNIT is the spring system, wherein just a spring stopper is there. You pull the spring stopper, and the spring pushes the dowel into another slot. All of these methods have been patented by us because we have indigenously developed them in the campus, and we have done extensive analysis of the various aspects of precast concrete pavement. One of the key aspects is the lifting analysis. So when the panel is lifted, we have constructed panel as big as 3.5 by 4.5, which comes out to be 6-7 ton of weight. So they are lifted at 4 points. So when these are the stresses that are developed in it. So as such, no reinforcement is required, but some nominal reinforcement is provided at the four lifting points, just to make sure that there are no accidents while handling the panel. And the threaded bolts, which is visible in the right figure, is the lifting mechanism we have developed. One female threaded bolt is inserted in the concrete, it is embedded in the concrete, and for lifting, the male bolt is tightened and the panels are lifted. Later on, that slot can be filled with grout. One of the key aspects, like I said, is the base preparation. If there's any gap in the base, there are a lot of stresses in the panels and the panels may crack. So this is one of the analysis that we do is how much width of gap can be tackled by the road itself, and we design our grouting ports accordingly so that the base receives enough grout so that it doesn't the air pockets are not there. This is a chart showing how the design of the precast concrete pavement is done. It is compatible with IRC 58. We did that specifically so that it is more acceptable in India. I'll skip the details of it. This is the first project that we constructed in VNIT campus itself, and it was India's first precast concrete pavement. To be more specific, it was pre-tension precast concrete pavement. So each panel was pre-tensioned, which helped in reducing the thickness. As can be seen in the details on the right side, the panel thickness was only 150 mm, whereas the adjacent panel was 250 mm thick. So we saved 100 mm thickness of concrete. And in road construction, that 100 mm thickness reduction for, if we consider for, let's say, 1 kilometer, it's a huge saving of material. In this, lateral dominant jointing system was used, the one which I had shown previously, and the panel sizes were 3 meter by 3 meter. Smaller sizes were used because this was just a trial stretch, a small 25-meter road. So after completion of this, we were able to have multiple publications based upon this trial in ASC, in Baltic Journal, in Iranian Journal, and we were able to publish it widely within India also. And these are the patents that we have got for this technology. And like ma'am had explained, we were blessed to be able to get added in IRC S3 committee. We are in the process of developing the code, IRC code for this technology. Of course, the code printing and publishing takes time, but the process has started, so that's at least there. So in order to get this technology more accepted, we had to get it added in schedule of rates. So this has been added in PWD schedule of rates in Maharashtra. So that has actually given a good boost to the technology, and we have started seeing some tenders that are being made so that they'll be published, and this technology will be more accepted once we get this process done. So once I had completed my PhD, so I took this technology as my business. So we started manufacturing of the panels. We took a few projects. As can be seen in the left side, a complete casting MS table has been made here. So what happens is that there's vibrators applied beneath the table. So that helps in compacting the concrete well. As has been explained in the previous presentations, the quality of precast is really up to mark. And if there is any issue in quality in any of the panels, the most critical activity for these panels is not the heavy loads that would be applied on them after laying of the panel. The most critical activity is here when the panels are lifted and transported. So if there is any defect in the panel which has skipped QA/QC controls and skipped checking, so that would be visible here itself. If the panel has to get damaged, it would get damaged here itself. So once the panels reaches the site and once they are laid, There won't be any flaws in them. Any flaws, if there are any flaws, they will be detected in the casting yard itself. Another casting yard has been established by us in Amravati, and these both of the casting yards is on the similar technology. So I won't dwell much on this slide. Right. After completion of this first project and establishment of yards, we were able to convince various companies regarding it. Ultratech gave us an opportunity in their RMC plant in Bangalore, and we constructed a trial stretch there of just 12 meters, based upon which we are in the process of having discussions with BBMP, and we'll be having a little, let's say, a 300-meter, I think, of road there where we will be constructing precast concrete pavement. One road which we have completed is in RAJEEV HINGNA. This is near Nagpur in Maharashtra, and we started in October 2019 this project, and we completed it really fast and got really good responses from the local people. The problem they had was this was the only road which had the only access point for the residential area ahead. So the road could not be closed, and whenever bituminous road was done there, there was a lot of problem of quality. So concrete road had to be constructed, but the authorities were wondering how can we do that. So that gave us a good opportunity, and we introduced precast here. It was 450-meter road length. The panel size was 2.75 by 3.5. The total width of the road was 5.5. So we had 2.75 and 2.75, two panels there. The PQC design here had a thickness of 300 meter. Cast in place concrete road had a thickness of 300 mm, and precast had a thickness of 200 mm. So again, 100 mm thickness saving. That's what we maintained here, and we got a lot of appreciation for it. In this, the sliding slot load transfer mechanism was used, like I had shown in the previous slide. The dowels were slid into the other panel, and the holes were grouted later on. So this photo is before the grouting process. Right, and this was the third project. This was again near Nagpur. Again, the situation was same, that the width available over there was really less. Had concrete road been constructed, diversion was not possible since alternate routes were small lanes where heavy trucks couldn't move. So we had to finish it very quickly. So we switched to precast. Just 125-meter was the length, which was congested. So we focused just on that much. And again, since the time it has been constructed, all of these projects are working very well. There has been no cracks in the road, no problem with the road, and it's been almost let's 3-4 years since the first project, so it is working really well. This was a 7-meter wide road, so we had 2.5 by 3.5 meter panels, 3.5 and 3.5 adjacent. We kept it there that way. This is another project which is ongoing. I have just came from the site actually. This is a really crowded area, Pathan Chowk in Amravati. The traffic here is so dense, it is really difficult to even walk there. And the traffic is dense till 11 o'clock, 11 p.m. And the traffic starts again, the morning vendors and all. There's a subsidy market here, so they start around 4 a.m. So we get a really small working window. There we are constructing precast concrete road. It is a 1.1 kilometer road, and we have completed around 100 meters. Today we completed 150 meters. We finished 50-meter more lane. This system is similar to sliding slot, just that in this the panels are slid and the dowel slots needs to be grouted and the base needs to be grouted. The grout material is also developed by us. Of course, we have optimized it financially and in terms of its strength. And as you can see here, half width has been covered here, and other half will take up as soon as this is completed. Once we started this technology, we had designed it for first project, and the authorities were a little dicey, like will we be able to design it properly? So they involved Dr. Parvini Mehdi into it. Dr. Parvini Mehdi is a payment engineer in California Department of Transport. He supported us a lot, he helped us a lot, he proof checked our design, he appreciated us for our efforts. And after his involvement and his visit, finally the authorities were at ease that they were ready to construct the first pavement, precast concrete pavement. And after that, once we completed the first project, we received a lot of appreciation for the work from even from Mr. Ullas Devaraj, who was Secretary PWD in Maharashtra, and Mr. P.L. Bongirwar. We got a lot of support from Bongirwar sir. He was involved with us from the first day, and till now he's involved with us. He's been actively participating in the development of code. He is the one who has been pushing for the development of code and manual for precast concrete pavement. And of course, when we constructed the first pavement, Gadkari sir was there to appreciate us. He was there in the IRC conference. He was involved in the IRC conference. He visited our site. He appreciated the effort, and he has been supporting us immensely in terms of, I should say, moral support more than anything else. So, and we have been appreciated by other journals and newspapers, and that has helped us a lot in growing. And finally, this technology is really new. It's been in the world for like 21 years, so and its design life is 30 years minimum. So there's no code for precast concrete pavement throughout the world. There has been manual for general guidance, and as every technology, this technology has a scope of improvement. It is still a young technology, it is still growing, and I would really appreciate everyone's comments and everyone's help in developing it further. And I thank everyone, especially ICI, for arranging this conference and giving me the platform to present this. Thank you.
Yeah, thank you, Ameen, for very interesting presentation. So we have a lot of questions lined up for you. So I'll go one by one. So mention about the temporary panels and which can be again used as a permanent panel. So the question is related to that. If a temporary panel is used, whether it is grouted, because if it is grouted, then how, I mean, it may get damaged while removing. So how it is done?
Right. For temporary panels, the design is a little different. So it is not grouted. We don't grout it. We kind of create a frame and lock the panels within the frame. So you can remove the locks and remove the panels. Right. So that's how we do it. And of course, you can get more details on the website also.
So another question is, you mentioned at the start one of the challenge with precast concrete roads is about the sub-base settlement. So we have a question related to that. What if there is settlement after complete placing procedure of payment? How it can be tackled?
Right. So let's say there's settlement beneath a concrete road or a precast concrete road. The result of that settlement would be the cracking of the panel, be it concrete road or precast concrete road. So the only way to correct it is if the crack is small, it can be corrected readily through suitable grouts that are readily available in market. If the panel is completely cracked, the only solution would be to remove the panel and replace it with another panel. And precast concrete pavement is more often used in US for repair of concrete roads rather than new construction.
Okay. So another question is, there are different gradients used in the road. So how they are applied in PPCP concrete?
Right. So there, I'll focus on three parts because this question is really good and we have faced this a lot. So as far as camber or super elevation is concerned, that can be handled easily because the base is prepared likewise. So the milling operation has to be done such that the required camber or required super elevation is in the base itself. So the panel just needs to be laid that way. And secondly, if there is any, let's say, profile L section is having undulations. I shouldn't say undulations. It's having a profile. So even then, there's no problem with laying of the panels. Thirdly, if there are curves, so for curves we have constructed trapezoidal panels to cater to the curve, and that again, as previous presenters have rightly mentioned, it needs a lot of planning and an accurate panel development.
Yeah, yeah. Thank you, Amin. So another question is, what is the minimum quantity of PPCP needs to be executed for it to be financial viable at the present approved dates or something like that? Anything you can comment on that?
A minimum of 4 kilometers. A minimum of 4 kilometers is required, not necessary at one location, but within the range of a plant.
Okay, okay, okay. Then we have a lot of questions. So, how differential chamber of pre-stressed slabs taken care of?
Right. Again, what I just said, like the base needs to be prepared such that the camber is already provided in the base. The same thing is done in cast in place concrete pavement, right? Where the base has been given the camber and the thickness is constant for concrete road. So same thing needs to be done in precast concrete pavement.
So I'll take one last question. So what are the grades of concrete used and any other toppings required after installation of panels on site?
So for we have done all of these projects are pre-tensioned concrete pavement, and for pre-tensioning the minimum grade is M40, and for PQC also the grade that we prefer is M40. So minimum is M40 that we have used. Of course, it can be increased more since it is a controlled environment. As for the topping is concerned, we don't need any particular topping, but once the panels are laid at site, it needs two types of grouts. One is the base grout. If there are any undulations, the grout fills up the undulations. And another is the dowel slot grout. So any gap in the dowel slot is filled with the dowel grout.
How differential camber of prestressed slab. So if the slab has a differential camber because of the prestressing.
See, what we are doing is we are pre-tensioning in one direction, right?
Okay.
And the casting is done within the yard in a controlled environment. The dimensions has got a tight tolerance. So the panel needs to be of a constant thickness and a constant size, irrespective of the site situation.
Okay, so
So
are you pre-tensioning it on both the surfaces or only one surface? Because generally hollow core slabs are pre-tensioned on one surface. So that is why this question has come up, whether it is pre-tensioned on one surface or both the surfaces.
it is pre-tensioned in only one direction, and other direction there are nominal reinforcements that have been provided.
If suppose there is a cross section of slab, then whether the pre-stressing strands are placed at top surface as well as bottom
And
surface, or they are only placed at the bottom surface.
the eccentricity is zero basically. So
Okay.
they can be placed at the center or in two layers, but the eccentricity has to be zero. Since in pavement, what happens is there are two types of movements, up and down, as the temperature changes. So it needs to be uniformly pre-tensioned.
So, I mean, we have another question for you. So, can you highlight more on the cost comparison with conventional concrete road pavement, including base preparation cost? I mean, the total cost.
So the base preparation remains quite same, just that the grouting is added. The total cost, if I say, of having a regular concrete road or precast concrete road. So the total cost of precast concrete road varies from 5 to 10%. It is more than regular concrete road, and we are in the process of reducing it further. Like we are presently researching into smaller size panels to compete with white topping and the newer technology related to concrete road. So it would optimize more.
One more thing I just wanted to ask you is whether the mix which you are using, especially for pre-stressing, you are using what sort of mix? Like it is with what slump basically in the concreting?
Right. So the slump that we have maintained is 50 to 60. Like it is a tight this thing mix, and there have been three projects that have been completed, right? So I've also got a suggestion to improve the reduce this cement content. by adding geopolymer, but I haven't looked into it. So there's a lot of scope of improvement in this technology.
Because in your thing panels, it is very important that you should have a joint should match properly. So what I feel, whether you have tried with the SCC also, self compacting concrete in that.
We haven't tried that because with a complete setup, the vibrations that are provided with the table and additionally from top, we have got a fair panels, as in the diagonal has a maximum error of 4 mm. So the joints have not been a problem in the
Okay,
latest projects. Yes.
right. Thank you.